Hi, Bearcats. The year was 2018, and the calculus AB students had to face a litany of painful FRQs. The first one from this section was question number 3, which we are going to talk about right now. So as you can see, once again, there are like very few styles of FRQs that they give you, and this is going to be the graph one. So this is the one where they give you a graph and they like, this is f or this is f prime. Like it's always going to be the graph or the graph of the derivative. And that's what all these questions are going to be. I'm going to be finding the area under this thing. I'm going to be starting at a point, finding the area of all the spaces and either adding or subtracting from that value. It's going to ask me to do all that. It's going to ask me about either a critical point or an inflection point. So I'm going to have to know when it goes from a positive or a negative value, meaning it's above or below. And then I'm going to have to know when the slope is going up or the slope is going down. And that's going to be the basis of all of these questions. There's that 99% chance you're going to be asked to do this on the AP test. So tune in. Here we go. So this one gives us a graph. And just like we said, it says this is going to be a graph of G. And then it says, by the way, G is actually the derivative of F. So if that's true, we might want to write that down, that G of X is F prime of X, because that tells us some important things. It also tells us that G prime of X, the slope of this, is the second derivative of X, right? So we use the first derivative for all these critical points, and the second derivative is going to be for concavity. So question 1 says, by the way, if f of 1 is worth, it also says that this function g is a piecewise linear function. Yeah, we see that. It's all piecewise and chunky. And then once I get to 3, this becomes a nice, easy parabola, which is 2x minus 4 squared. So it says if f of 1 is worth 3, find f of negative 5. So it's going to give us our initial value. Our initial value is at 1. F is 3. So let's think about this. If f prime of x is this, that means that f of x is the integral of g of x dx, which means the area under the g of x curve, right? So that's really about what we're talking about here. I'm going to do some values and I need to figure out where I am. It says you're going to start at 3, which means at f of 1, at this point right here, at that point, f of 1 is worth 3, right? So every time I go to the right, I'm going to add the areas, and anytime I go to the left, I'm going to subtract the areas. So it says find f of negative 5. So that means I got to start at 1, right? I'm going to be like, all right, cool. I'm going to start at 1, and then I'm going to add. Well, I got to go backwards, right? So I'm going to have to go from here to there. So I'm going to have to subtract the integral from 1 to 0. I guess adding 1 to 0 is the same as subtracting 0 to 1, right? So I would subtract that triangle right there. Let's just do it like this. I don't like this. Let's just say this has an area of 1. Area from here to here is 0. Area from here to here is going to be, area of the triangle is 1/2 base times height. So this is going to be 1.5. And then the area of this big triangle here is 9, right? So I'm going to start at 3, and I'm going to count backwards 1. So it's going to be 3 minus 1. And I'm going to keep going backwards minus 0. And then it's going to go here. So remember, this is below the axis. So I'm going to be subtracting it. And it's backwards also. It's going to be a minus negative 1.5. And then I'm going to have to go backwards again. And it's below the axis, so that's another double negative. So I'm going to get 3 minus 1 plus 1.5 plus 9 for a grand total of 10.5, 13, 12.5. Boom. All right, let's see how we got our points for that one. So here we go. Okay. So if we want to get full credit for this, we do have to make sure we put down this integral. So it says we're going to start at 1, and then we're going to use the integral from 1 to -5. So I probably should have finished my initial thing when I initially started doing it. I started writing the integral. I should have probably wrote that. Right? It's going to be the integral from 1 to -5. You don't have to break it up. You can write it all in one chunk. Right? So it's going to be that plus the integral from 1 to -5. And I notice how they made it backwards. From 1 to -5, I probably could have written minus the integral -5 to 1 because those two things would have been the same. Correct answer was 12.5. All right, part B. Part B says, hey, I need you to do me a favor. Find me the value of the integral from 1 to 6. So it doesn't matter where it starts and finishes. Remember, the integral from 1 to 6 is just the area from 1 to 6. That's all I'm looking for. So the area from 1 to 6 is going to have two pieces. It's going to have the area from 1 to 3, right? The integral from 1 to 3 of g of x dx plus the integral from 3 to 6 of g of x dx. This first one's super easy. The integral from 1 to 3 is just 4, right? However, the integral from 3 to 6, that's a curvy area. So I'm going to have to refer to this g of x. But I should be able to just find the integral of that. So let's see what they got for their totals. So here it is. They started with, there it is, the integral from 1 to 3 of g of x, right? And then they had the integral of that. They did write this as the integral of the line 2, which is turning out to be just 4. We know it. We can count the squares. We don't actually have to do that. I like the way they did this integral. They're like, dude, if u is x minus 4, then du is dx. So they just kind of integrated this. They didn't break this whole thing down. When I did this, I actually turned this into 2 and then x squared minus 8x plus 16, which turned into 2x squared minus 16x plus 32. And then I integrated all of that. It gets me the same answer. It's just not as concise. They're like, if you just integrate this with u substitution, you're going to get this. All right, cool. Then I plug in a 6, that gets me this one, and I plug in a 3, that gets me this one, and I'm going to be left with a grand total of 10. So I get a point if I split this up at 3. I did the two integrals. I get a point if I have the correct antiderivative of that. Remember, that would have been okay, or well, it would have been, sorry, let me rephrase that. It would have been 2x cubed over 3 minus 16x squared over 2 plus 32x from 6 to 3, right? That's the other version of that I could have had. I would have got a point for that and then a point for the answer. All right, part C. It says, from -6 to 5, in which open intervals is it both increasing and concave up? All right, so for increasing, I would have to know when f prime is positive. And remember, this is the graph of f prime. So it's going to be positive everywhere from 0 to 6, right? So from 0 to 6, it's positive. So that's increasing. And when is it going to be concave up? Well, you know what? Concave up is when it's going uphill. So if all I'm looking at is the values from 0 to 6, right? If it's concave up, it's going uphill from 0 to 1, and then it goes flat, and then it goes downhill from 3 to 4. Oh my God, this is the worst thing ever. This is why you don't try to do all your work. Do your work on a separate sheet of paper, kids. Learn a lesson. This is going to be negative, and then from 4 to 6, it's going to go positive again. So you can see when it's going to be positive. So it's always going uphill from 0 to 6, but only from 0 to 1 and from 4 to 6. Here and here is the second derivative going to be positive, or the second derivative going to be positive, therefore it's concave up. So I should get those two things as my answers. F prime of x is increasing and concave up because the first derivative is greater than 0. That's increasing. It doesn't say anything here, but it should also say the second derivative of x is greater than 0 from 0 to 1 and from 4 to 6. So it should also include that, but it doesn't. So I don't know. Okay, part D, last chunk, says find the coordinates of each point of inflection. So remember, point of inflection, f double prime changes sign. And f double prime is, once again, g prime, right? So when does g prime change its sign? When does it go from uphill to downhill? So look at my graph. Graph's flat, uphill, flat, uphill, flat, up, flat. So it goes from flat to downhill. That's not changing sign. It goes from downhill to uphill. So it changes. So g prime changes from negative to positive. Therefore, inflection point at x equals 4. So right here it goes from downhill to uphill. And there it is. The graph of f has a point of inflection s equals 4 because f prime equals g of x changes from decreasing to increasing, right? When it says it changes from decreasing to increasing, it means f double prime changes from negative to positive, right? At x equals 4. All right, hopefully you got through that one. Guarantee you it's on the test. Redo it, think about it, do it again, check it again, make it happen. Good luck. Catch you next time.